Good morning, students. So, welcome to class of physics, and in this class we are going to start a new chapter, that is electrostatic. Okay. So, before moving to electrostatic, let's know what is electrostatic and what is the history behind electrostatic. Okay. Simply, if we observe the term electrostatic, we find generally it is combination of two different terms. One is electro and another one is static. Okay. Electro means that is charge. Okay. Either electron or proton. Okay. We discuss later what is electron and what is proton. Okay. Another thing, that is static. Static means rest. Okay. And electrostatic means charge at rest. Okay. So that means we can say it is a branch of physics which deals with the study of charges at rest. Charges at rest. Okay. And if we move to the history of electrostatic, the story of electrostatics starts from 600 BC. Okay. That means we can say in 600 BC, one of the legendary scientists, or we can say that is Greek philosopher, Thales of Miletus, okay, while moving in the shore of Baltic Sea, he find a substance which has property of attracting small bodies towards itself, and the property of attracting arises when the substance is rubbed with silk, or you can say that is silk or any other substance like woolen cloth. Okay. So Thales of Miletus, that is we can say in 600 BC, Thales of Miletus, while moving in the shores of Baltic Sea, he found a substance named amber. Okay. That means a amber is a hardened material of pine tree, or we can say it is a yellow resinous material, that found in the shore of Baltic Sea. Okay. It is a hardened part of a pine tree. Okay. And when Thales of Miletus, while moving on the shore of a Baltic Sea, found a amber, that is the yellow resinous material, and when the amber is rubbed with silk, it acquires a property of attracting small pieces of substance towards itself. Okay. But at that time, Thales of Miletus does not give a proper explanation how this happens and what is the cause behind the attraction of amber or attraction property of that small materials towards the amber. Okay. And the total phenomena was again given by or observed after 2000 years. Okay. After 2000 years, another English scientist, William Gilbert, okay, after 2000 years, the same effect was observed by an English scientist, that is William Gilbert. Okay. Another scientist we can say, that is William Gilbert, discussed the same type of phenomena that observed by Thales of Miletus. Okay. William Gilbert observed that a amber, like other substance, has also the same property of attracting when they are rubbed with silk or woolen cloth or any other substances. Okay. That means the attracting property does not exist in case of amber, but besides amber, some other substances also have such property like amber. Okay. And Gilbert named that effect as electric attraction. Okay. That means we can say Gilbert named that attraction property of these substances as electric attraction. Okay. But as in Greek language, amber is known as, in Greek language we can also know amber means electron. Okay. Amber discussed as electron in Greek language. Okay. And Gilbert characterize amber as electron, and it has a property of attracting small pieces of substance towards itself when rubbed with silk or woolen cloths. Okay. And in 1671, another scientist, that is Otto Hahn, first give the idea of force of attraction and force of repulsion depending upon the depending upon the friction, and when by this friction Otto Hahn observed there are two different effects, that is the repulsion effect and another effect is attraction effect. Okay. So, these are the some few histories about the electrostatics. Okay. Now, let us discuss how we can produce charge body and what are the different charge bodies. Okay. So, before moving to different charges and what are the process of charging a body, we should know what is charge. Okay. We can say charge means it is a fundamental property of any substance. Okay. Charge is a fundamental property of any substance or matter that obtain because of friction, and it produces two main effects, that is electrostatic effect, or you can say electric effect, as well as magnetic effect. Okay. So, in details we can say that is charge means a charge is a fundamental property of any matter obtained by rubbing one body with other, and it has a property, it has the property to show electric and magnetic effect, or we can say simply electromagnetism. Okay. So, charge is a fundamental property of any matter that is obtained because of friction of one body with another. Okay. Suppose we take this one is a one matter, this one is another type of matter, and when we rub one body with another, then there is a transfer of some elementary particles, and because of that transfer two body will be charged, and this charged body has the property to show electric effect as well as magnetic effects. So, combinedly both effect is known as electromagnetic effect. Okay. So, because of charging a body we can observe both electric effect and magnetic effect. Okay. Now, question arises, what are the different type of charges arise when we rubbed one with another. Okay. So, in order to solve this question we have to move towards atomic physics. Okay. As we have already discussed in your previous classes in atoms. Okay. So, if you have not watched the atoms, so watch atoms that are available in your YouTube channel. Okay. And from that atom you can find the idea about that atom, its structure, and what are the different phenomena associated with the nucleus. Okay. So, in order to find what are the different type of charges exist in nature, we can take a help of one atom. Okay. So, generally as per Rutherford's theory, an atom is being neutral. Okay. And the neutral property of atom, because of a presence of equal amount of charges, one is positive that lies inside the nucleus, while the negative charge electrons are revolving around the nucleus. Okay. The total positive charge of an atom always exists inside the nucleus, and the cloud of negative charge lies outside the nucleus, and their value are arranged in a rare manner. That means most of the space of an atom is empty. Okay. And this theory was given in Rutherford's alpha particle scattering. Okay, or Rutherford's experiment. Okay. So, as a whole atom is neutral. Okay. Neutral means it contains equal amount of charge. One is positive, that is proton, another one is negative, that is electron, and there is a cloud of electron lies in the outermost case of a atom. That means at the center there is nucleus, and around the nucleus the electron are revolving in a circular orbit, and they make a electron cloud. Okay. So, as a whole we can say atom is being neutral. Okay. So, atom is neutral. Okay. And when a neutral atom is considered, means we can say it contains equal value of positive and negative charge. Okay. And the positive charge lies inside the nucleus, and negatively charged electrons lies outside the nucleus. Okay. And we have already discussed in atoms that the electrons arrange in different orbits. Okay. And when we move away from the orbit, the force of nucleus or the attraction effect of nucleus on electron gradually decreases. Okay. That means the force of attraction, electrostatic force of attraction between nucleus and electron gradually decreases as we move towards a outer orbit. Okay. That means the electrons lies in the outermost orbit, in the last orbit, they are generally loosely bound with the nucleus. Okay. And those electrons are called valence electrons. Okay. Those electrons are loosely bound to the nucleus, or the electrons which are lies in the outermost orbit of an atom, they are generally loosely bound to the nucleus, and they can be removed by the help of small amount of energy. Okay. That means we can say, we can take a small example. Suppose we calculate the energy of electron in the 5th orbit. Okay. So, we can say the electron that lies in the 5th orbit generally possesses minus 0.54 electron volt of energy. Okay. Minus 0.54 electron volt of energy, and that electron can be removed if we provide plus 0.54 electron volt of energy. That means a small energy can be remove the outermost electrons. Okay. But you may say the electrons which are close to the nucleus. Suppose we take another case, the ground state energy of electron. In case of the electron that lies in the ground state, it possesses energy minus 13.6 electron volt, and this can be removed if you add plus 13.6. That is a large amount of energy as compared to outermost electron. Okay. So, those outermost electrons are generally loosely bound to the nucleus, and they can be removed with the help of a very small amount of energy. Okay. So, while charging a body or while producing charge from a body, always the outermost electrons take part in the electrification process. Okay. Suppose being neutrality of an atom, so we can say it contains equal amount of positive charge plus equal amount of negative charge, that is why total charge equals to 0. Okay. Suppose we consider, or we can understand this in more details by taking a suitable number of example. Okay. Suppose we take two different elements. Okay. Two different elements like hydrogen and suppose any two substance, hydrogen and oxygen. Okay. Hydrogen and oxygen. Now let us take oxygen only. Okay. Oxygen nucleus has 8 number of, remove this, it contains 8 number of protons. Okay. In case of oxygen nucleus, there are 8 number of protons inside the nucleus. That means there are also 8 number of electrons outside the nucleus. Okay. So, there will be plus 8e because of proton and minus 8e because of electrons, and total charge will be 0. Okay. And when oxygen element is subjected to electrification, and the oxygen element contains 8 electrons outside the nucleus. Okay. So, in case of this arrangement, we can say the electrons that lies in the outermost orbit. Okay. Suppose we write the electronic configuration as 1s2, 2s2, 2p4, okay, 2p4, okay. So the outermost orbit of the electron will contain 2p4, okay. So 2p4 means we can say there is a possibility that the electrons value here may be 2p6, okay, maybe 2p6. That means there will be the electron, the oxygen can accept 2 more electrons, okay. Oxygen can accept 2 more electrons in order to complete its piece of shell, okay. And when the oxygen is brought near 2 hydrogen atoms, okay, if we bring 2 hydrogen atoms, in case of hydrogen there is 1H1, okay, and if we bring 2 different hydrogen atoms, in hydrogen simply we can say the electronic configuration is 1s1, okay. The electronic configuration is 1s1 means it contains only 1 electron, okay. So this 1 electron can be shared by this oxygen nucleus, okay. And because of sharing, if we take 2 different hydrogen atoms, that means these 2 electrons will share with the oxygen nucleus. That means when we rub 2 oxygen atom with oxygen, 2 hydrogen atom with oxygen, then what happens? The hydrogen nucleus remove 1 electron from one oxygen from one hydrogen atom, and that electron is received by oxygen, okay. And if we take 2 different hydrogen atoms and both the hydrogen lose one of its electron, then what happens? These 2 electrons was received by oxygen, okay, and that becomes 2p6, okay. But question is that oxygen receives 2 electrons from 2 hydrogen atoms, okay, and because of that property the oxygen get 2 extra electron, means it has extra 2 charge. So here the total charge will be 8 protons, 8 electrons, and net will be 0 in case of oxygen. But what happens? Electrons receive 2 electrons from 2 hydrogen atoms, means it has 2 more electrons, 2 more electrons, okay. And when 2 more electrons added to the oxygen, so what happens? Its remaining charge will be minus 2e, its charge will be minus 2e. Minus 2e means we can say it has 2 extra electrons, and net charge on that oxygen will be negative, okay. And if we move towards the hydrogen atom, what happens? In case of hydrogen there will be 1 proton, 1 positive plus 1 negative, okay. And when hydrogen lost 1 electron, means its negative charge is removed, okay. And when the negative charge is removed, the remaining charge in the hydrogen nucleus will be plus 1, okay, and it becomes positive charge H plus, okay. And in order to balance we are taking 2 hydrogens, okay. So that's why we form H2O like molecule, okay. In H2O molecule simply we can say there are 2 extra electrons of hydrogen was received by oxygen to form a water molecule, okay. Understand? Suppose I take a very easy example to make you clarification by taking a simple example, okay. Suppose I take a substance that contains 4 protons inside the nucleus and 4 electrons outside the nucleus. Okay. So, net charge in that substance will be 0. Okay. And when that substance is rubbed with a body, suppose it receives more electrons, it receives 5 more electrons. Okay. And when it receives 5 more electrons, what happens? Its positive charge remains same. Okay. With the negative charge also there, and and it receives more 5 electrons, means more 5 negative charge is added to that atom. Okay. And when more 5 negative charge is added to that atom, so net charge of the system will be minus 5e. Okay. So that means its charge is negative. Okay. Because of absorbing electron or receiving electron. Okay. So we find two different things. A body lost its electron and a body gained the emitted electron. Okay. And the body which lost the electron becomes positive charge, and the body which receives the electrons, that becomes negative charge. Okay. And during the friction, there is only transfer of negatively charged electrons. Okay. Protons cannot be transferred in electric friction or electric rubbing, because protons lies inside the nucleus, and as the electrons are the outermost element or outermost substance of an atom, they first take part in reaction. Okay. And in an electrostatic rubbing, always there is a transfer of electron from one body to another body. Okay. And the body which receives the electron or which absorbs the electron becomes negative charge, and the body which emits the electron becomes positive charge. Okay. So this is a example that we can say process of charging a body. So what we get? So generally we get there are two different type of charges. One is positive. Okay. So charge is divided into two different categories. One is positive, another one is negative. Okay. So one is positive charge and another one is negative charge. Okay. And the negative charge, as per Benjamin Franklin, when we take the example of amber, simply amber is named as electron. In Greek word, amber is known as electron, and the property of charge that arises in amber is negative in nature. Okay. So that is, we can say amber is a resinous substance that produces negative charge. Okay. So we can say the amber is being a negatively charged substance. Okay. So one is positive nature, and the positive nature we can take an example as proton, and a negative nature, that is a electron. Okay. So electron is being negative and proton is being positive. Understand? Now we can take what are the different process of charging a body. Okay. So what are the different method that we can charge a body. Okay. And when we take the case of atomic physics, we can say charge of proton and charge of electron are same. That means magnitude of charge of proton and magnitude of charge of electron. Okay. That value will be 1.59 into 10 to the power minus 19 coulomb. okay, or we can say that value will be 1.6 into 10 to the power minus 19 coulomb. Okay. The magnitude of electron and magnitude of protons charge are same, and the value will be 1.6 into 10 to the minus 19 coulomb, but electron is being negative, proton is being positive. Understand? Second thing, mass of proton, that will be 1.67 into 10 to the power minus 27 kg, whereas mass of electron, that will be 9.1 into 10 to the power minus 31 kg. So, electron being a light mass particle, okay, that means it has a very small mass, and its charge is equal to charge of electron, that is minus E, and charge of proton, that is plus E. But magnitude of charge of electron and magnitude of charge of proton is equal to 1.6 into 10 to the minus 19 coulomb. Okay, understand? Now, let us take an example or more about the process of charging a body. Okay, so generally we can charge a body by 3 different process. Okay, so method of charging a body generally method of charging a body. Okay, so generally we can use 3 different method to charge a body. Okay, so first is charging by friction. Charging by friction. Second, that is charging by conduction, and third, charging by induction. Okay, so these are the 3 different methods of charging a body. Okay, so first let us discuss about charging by friction. Okay, so charging by friction, or simply we can say frictional electricity. Okay, so frictional electricity says that when a body is rubbed with another body, then what happens, there is a transfer of electron from one body to another body. Okay, so you can say when a body is rubbed with another body, okay, that means when we make friction in between 2 different bodies, and because of friction there is a production of energy. Simply when we rub your hands, there will be warmth. Okay, there will be short amount of heat energy produced because of rubbing one hand with another. Okay, and when we rubbed one body with another, there is a production of heat energy. Okay, and because of that heat energy, an electron is removed from its outermost orbit, and that electron is received by the other body. Okay, so when one body is rubbed with another body, there is a transfer of electron in between the bodies. Okay, and the body which receives the electron being negatively charged, and the body which donates the electron being positive charged. Okay, and that process is called frictional electricity. Okay, or charging by friction. The body which receives the electron is negatively charged, and the body which absorbs the electron, the body which absorbs the electron or receives the electron is being negative charge, and the body which donates the electron, that becomes positive charge. Okay, and always remember, there is a question arises, is there any loss of mass in a atom when there is a transfer of electron, okay, and the question is the answer is yes, because a electron has a very small mass, okay, and when electron moves from one body to another body, there is also loss of a few mass of that atom, okay. So when there is a transfer of charge from one body to another body, so there is also a change of mass, okay. Now let us take discussion about charging by conduction, okay. What is charging by conduction, okay? Charging by conduction, we can take an example like, suppose a body is positive charge, a body is positive charge, suppose we take the body as A. Charging by conduction, suppose we take one body A is being positive and it contains large amount of positive charges, okay, and there is another body B and this body B is being neutral, okay. The body B is a neutral body and the body A is being positive charge. Suppose this is the first case. In second case, suppose we make contact with body A with body B. There is a contact in between body A and body B by a conductor, okay. That means body A and B are joined together, okay, and when body A and B are joined together, we can say there is transfer of negatively charged electrons. The body B is neutral, being means it contains equal amount of positive and negative charges. It has the total positive charge is equal to total negative charge, that's why it is being neutral, okay. When there is a contact region in between A and B, what happens? From body B there is transfer of electrons towards body A, okay. From body B electrons are transferred to body A because body A is positive charge and it contains large amount of positive charge. So that's why some electrons from body B transfer towards the body A and those electrons neutralize the positive charge present in A, and the transfer of electron takes place up to a region that the total positive charge in body A is equal to total positive charge in body B. Now now question arises, how a body B is being positive charge, okay. The body B is being positive charge, it means when the electrons flow towards the A, they left some charge that is positive. As I discussed in the frictional electricity, when the electron is removed, the body is being positive, and when the electron moves from body B to body A to neutralize that positive charge in A, it left charge in B is positive, okay, and the number of electrons that moves towards the body A depends upon the charge on body A. That means they move until the positive charge in body A is equal to positive charge in body B. So because of transfer of the negative charge electrons from body B to body A, the body A, sum of the positive charge in body A is neutralized and a few number of positive charge will left in body A, and that value is equal to the positive charge produced, the positive charge produced in body B. That means charge of A is equal to charge of B, okay, and that happens when the body is connected to each other, okay, and that process is called charging by conduction. The body B is neutral, okay, but when there is a contact region between A and B, electrons moves from body B to body A to neutralize the extra positive charge present in A, okay, and that movement is up to a limit that charge of positive charge of A is equal to positive charge of B, okay, both remains equal charges, okay, and that process is called charging by conduction. That means charge can flow through a conductor, okay, and this process is called charging by conduction, okay. Now take the last one, that is charging by induction, okay. Charging by induction means we can say suppose one body is positive charge, suppose we take body A, okay, and another body B is being neutral, okay, and brought the body B, that is the neutral, towards body A, okay. In second case, what happens when body B is brought near to body A? What happens? Because of the positive charge of A, there is a arrangement of the electrons in the one side of body B and equal amount of positive charges arranged on the opposite side of body B, okay, but there is no contact in between A and B. When body B is come close to body A, what happens? There is production of positive charge on the side, production of negative charge on the side of positive charge and equal amount of positive charge on the opposite side, and the negative charges lies in the one place because of positive charges of body A, okay. These positive charges attracts all the negative charge present in B towards one face, okay, while all the positive charges arranged in the opposite side of body B, okay. Now if we so if we made earthing, okay, suppose we make body B, or if we join body B towards the earth, then what happens? The negatively charged electrons from earth move towards the body B and they neutralize all the positive charges lies on the other side, okay. And when the negative charge electrons moves from earth to neutralize these positive charges, then what happens? The remaining charge in body B will be the negatively charged electrons, okay. Suppose the electrons moves from earth to neutralize these positive charges, and what happens? For body B, there is only negative charge left, okay, remove, okay. After being neutralized, remove the earthing, okay, and when we remove the earthing, what happens? The negative charges lies in the body B, okay, and when we again make a distance between A body and B body, suppose we again make a large distance, or we can say when the body A or the body B is taken away from body A, or taken away from each other, the negatively charged electrons uniformly arranged inside B, and the body B is being negative charge. Okay, and that negative charge is induced or produced when a positively charged body brought near a neutral body. Okay, but there is no contact region. Okay, when a positive charged body brought near a neutral body, then what happens? There is induction of charge, and that effect is called charging by induction. Understand? So, these are the different steps that we discuss. Okay, I repeat, a body A is positive charge, body B is being neutral. Okay, and when we brought body B towards body A, what happens? Towards the positive charge, or because of positive charge, negative charges arranged on one side of B and equal amount of positive charge arranged on the opposite side of B. Okay, suppose we make that opposite side with earth, or suppose we join this side with earth, then what happens? The electrons from earth move towards body B in order to neutralize the positive charge, and after neutralize, remove the earthing. Okay, and the left remaining charge will be negative inside B. Okay, now